what were your questions here? The math part. Okay, well, good. We'll do this methodically. So note here. Okay, good. 2 and 4. Good. So this is what I was planning, Kristen, to go over, which is that point about total revenue and how it relates to the demand curve. So we'll be doing more on that today. Let's get started with looking at this. So here is the elasticity of demand formula for the coefficient. And so this is the midpoint formula that number 1 relates to. And then it asks, what's the elasticity between 20 and 30? And so let's add here, if you don't already have it in your notes, let's add it here. P1 would be $20. P2 would be $30. Now look at the corresponding prices. So this is maybe what some people are stuck on. Look at the price, take it over to the demand curve, and then follow it downward to the quantity. So Emma, what do you see for quantity 1? What would it be at the price of $20? What do you see the corresponding value? Okay, Nathan, gotcha. We're all together. We'll work through this together. Yeah, good, Emma. So at $20, you take a demand curve, then your quantity is correspondingly 40, and then your quantity for the next point, the price of 30. Notice 30, take it to the demand curve and down, that is 30. And so now let's set up our formula. So remember how I did it last class, and that is one long line for the numerator and denominator. Let me actually do this down below where I have some more white space. And so following along with how the formula works, we have quantity 1, which is 40, minus quantity 2, which is 30, which itself is divided by quantity 1, which is 40, plus quantity 2. And here it doesn't matter the order of how you do this because they're going to be added together. 30, which that itself is divided by 2. So there's our numerator. Our denominator is going to be the price. So P1 minus P2, same basic framework for the formula above with quantity. So P1 is 20 minus P2 is 30. With that divided by those two added together, those two prices added together, 20 plus 30, then that divided by 2. And so note what we're doing when you take 2 things and divide it by 2, or you take 3 things and you divide it by 3, or you take 4 numbers, you divide it by 4, what's that's giving you is an average. So remember, again, this is somewhat imprecise and that we're not getting the exact elasticity at one price, we're getting the elasticity in the range between the two. Now, if we simplify this and try to be really methodical about this and not rush it. So we'll have 40 minus 30, which is 10, divided by, then note, let's nest this, let's do this whole nest right here. 40 plus 30 is 70, and then 70 divided by 2 is 35. Then in the denominator, 20 minus 30 is negative 10, divided by, now we have 20 plus 30, so 50. 50 divided by 2 is 25. Okay, now what do those, use your calculators to determine what that comes out to in terms of once you divide the numerator by and the denominator, so 10 divided by 35 and a negative 10 divided by 25. And then remember, so that we're all in the same place here, getting the same answers, round it to the nearest hundredths place, to the second decimal place. So Kristen, and somebody check in if that's not, but that looks right to me, having done this problem for a number of years. Good, good. So we have in our numerator 0.29, sorry, 29, and then our denominator negative 0.4. And then when we divide those two, what are you coming up with? Well, we've got it right here, right? 0.73. But remember, the point is, and part of the notes last class was that economists always show that in absolute value terms because we assume, notice this demand curve, there's a negative relationship between prices and quantity, right? As prices drop, quantity people demand increases. That's why we take away the negative sign, but this should give you, so we do this math, let me just double check it, for me to be making an error here. Yeah, good. So that comes out to be negative 0.725. But remember, we're always wanting to distill things down to 2 decimal points. And so we've got negative 0.73. Now, what that tells us is demand for this product is inelastic. It's inelastic in the sense that down here at between $20 and $30, if you actually raise your price, you are going to make more revenue. And so just think about the definition of inelasticity, that it means that somebody isn't very price sensitive. They don't feel they have substitutes. And right at that price and that quantity, you might lose a few people in selling your product, but you're going to gain more revenue given that it's an inelastic demand. And so at that point, whenever you have inelastic demand along a linear demand curve, you're going to want to raise your prices. And if you raise your prices, you're going to increase your total revenue. And I'm going to give you another way to look at that and draw it out mathematically in a second. But Emma, does that help at least with the first 2 questions? Does that make sense so far? Okay, good. So let's
Steve,
do.
I had a quick question before we keep going.
Of course.
On that same problem, for whatever reason, I had my numbers backwards. So I did 30 minus 40, and on the bottom, I did 30 minus 20. And I still came up with the same final answer. Is that okay?
Yeah.
Or should I like?
Yeah, that's absolutely fine. I've done that when I've done this calculation in front of classes, and it's the same thing because you're just determining, instead of having the denominator negative, you had the numerator negative, but either one being negative makes the outcome negative. So yeah,
and it's still the same numbers. Okay, cool. Thank you.
And other of you,
Steve, clarifying.
And others of you might see other ways. Others of you might find other ways to solve this problem because math has many directions to come to the final right answer. But this is just the way I teach, so we're all on the same page. Did somebody else have a question or comment?
I was going to say, clarifying that. So does it ever matter which number you're going to use as Q1 or versus Q2? Or they always be interchangeable?
Not in this formula. They're always interchangeable using this formula.
Okay.
So as long as you're consistent, it'll be fine.
Yeah, exactly. But yeah, I'd say try not to do that to confuse yourself, but it's going to work just fine. It's the nature of this being an average. And so let me just state that if this was calculus and we were taking the first derivative, it all matters. But the way this is taken and the fact that it's an average between 2 prices, it's less precise. Therefore, this adherence to exactly what this rule is a little bit flexible. Now, what isn't useful is if you flip the numerator and the denominator. That is, if you put the price changes in the numerator and the quantity changes in the denominator, then you're completely opposite, right? This 0.29 and negative 0.4 would be the opposite, and you get the opposite answer. Okay, so I'm going to come back over here and now redo this for number 3, which is 50 and 60. So look at 50 and 60 and look at the corresponding quantities. So 60, or quantity 2, would be 0, and 50 would be 10, right? Again, we're looking at the price, taking it to the demand curve, and looking at the value on the x-axis. Then coming here, let me just, and if you would, do the same thing here if you haven't already in your notes. I'd like to see all this detail here in your notes. So I'm going to come to, and I'm just going to delete the values here. And so here, note we're going to put Q1 minus Q2, so 10 minus 0, and then 10 plus 0. And then down the denominator, again, we're looking at price in the denominator. So price would be 50 minus 60, and 50 plus 60. And no, I'm just saying the things that I'm plugging in here. Of course, there's the rest of the order of operations to complete there. And so now going step by step here, in the numerator, take 10 minus 0, that's going to give me 10. In the numerator, up in the numerator. And then you divide that by 10 plus 0, 10. 10 divided by 2 is 5. Denominator, 50 minus 60 gives us negative 10. That then divided by 50 plus 60, which is 110. Divide 110 in half, you got 55. Okay, so now somebody else tell me, what do you get for your numerator and denominator here? Well, here, 10 divided by 5, I don't think we need our calculators. I hope not. 2. And yeah, so Nathan, you just flip the Q1 and Q2 or P1, P2, all good. And then negative 0.8. So one of the two needs to be negative here. You know you're doing something wrong if one is a negative, even though we express it in absolute value terms. And once you divide one by the other, just double check my answer is correct that I've given you. Yeah, you get 11.11 reciprocal, meaning that that 1 looks like it's repeating indefinitely. So we're going to just round to the hundredths place. We get negative 11.11. So up here, where your prices are relatively high, notice that elasticity of demand becomes elastic, meaning people are very price sensitive. Also, another way of thinking about this is the highest possible price that you can have demand for your product. And so you're really eking out just the very few who absolutely are desperately needing your product. If you're going to want to increase your total revenue, mathematically, as we'll see here in a second, you're going to want to lower your price, but think about it logically. People feel that at $50, $60, that they've got other substitutes for this product. It's just not worthwhile to spend that kind of money for this product. But as you lower the price for the product, then more people are going to want to buy that product. And even though you're lowering the price, you are increasing the volume of customers enough that it actually will increase your total revenue. So this is, like we were talking about last class, this at times is the counterintuitive part of elasticity of demand, is that at times when your demand is elastic along your demand curve, you're going to actually want to lower your price, because in lowering your price, you're going to be able to get much more customers to pay that price than you're going to lose in the revenue by lowering that price. And so to answer number 4, you would reduce your price to increase your total revenue. And remember, what your goal is, in fact, you tell me, what do you want, what should your elasticity of demand be to know you've maximized your revenue? Yeah, good, Nathan, exactly, 1. And if you would, Nathan, take yourself off of direct message, just if you're answering my questions. Does that make sense, Kristen? And I'll come back and we'll look at this again, Kristen. And Daisy, thank you. So Emma, no, it's all good, Nathan, just want to make sure everyone sees each other when they're participating. Emma, how do we look? Nathan, you'd said you wanted me to go over this. A little bit better?
Yeah, much better.
So we're going to hit this in another way as well. Okay. Okay, so what I'm going to do now is move us, and I want you to do the same, move us to the total revenue test. So the other link I wanted you to open.